Hi guys, I'm Fatima Galupo.
Hi, I'm Francis Angelo Abainza.
And I am Ken Capay. If you remember the three of us, we actually did one video about application of physics to psychology. So it is actually a tough topic to ask someone or to discuss the connection of physics and psychology, especially that they are in different field of science or they are in different sides of sciences. But if we go in detail, we actually can explain something with the help of both physics and psychology, more specifically in cognitive psychology. Because in our previous vlog, we just discussed how MRI, CT scans have the physics related concepts and the connection to psychology. But one of the cognitive processes in psychology is called decision making, and it is from a course of belief and action of an individual that produces their final choice or decision in life. Some of its factors are past experiences of an individual, cognitive biases, differences in age, belief in personal relevance, and an escalation of commitment. Same with heuristics, where it is considered as a mental shortcut that allows people to solve problems, make them and make judgments quickly and efficiently. So how can we actually connect these cognitive processes of psychology to physics itself?
So to answer your question, just remember that the next time someone accuses you of making an irrational decision, just explain that you're obeying the laws of quantum physics. You're not irrational, you're just quantum probabilistic. A new trend taking shape in psychological science, specifically in our cognition, is a matter of quantum physics, which is particularly useful in explaining humans' paradoxical thinking or when we behave in ways that seem irrational under classical probability theory. Insert quantum cognition, a new research program that uses mathematical principles from quantum theory as a framework to explain human cognition, including judgment, decision making, concepts, reasoning, memory, and perception. Wang and her colleagues spell out their new theoretical approach to psychology by trying to model our decision making processes mathematically, where equations and actions that most closely match human behavior may be ones that are rooted in quantum physics.
So, my take on the question, how do you relate physics with cognitive processes and decision making, is that according to the study that we found, quantum mechanics describes the behavior of tiny particles that make up all the matters in the universe, namely atoms, and their respective subatomic components. One central tenet of the theory in quantum mechanics suggests that there is a great deal of uncertainty in our world, something that cannot be seen or measured in larger scales. For instance, in this world of ours, we can predict where the train will go and how fast it's traveling at its destination. And because of the given data, we can predict where and when the train will arrive at its next station. Moreover, let's say that this train is an electron. From there, our predictive powers are no longer present because, let's face it, we can never know its exact location and its momentum. However, you can calculate the probability that the particle may appear in a certain location, traveling at a particular rate. And that way, you can get an opaque idea of what the electron is up to. With that said, just as uncertainty pervades the subatomic world, it is also evident in our decision-making process, whether we're debating what series to watch next or who you're voting for in the upcoming presidential elections. That's where quantum mechanics come in. Unlike classical theories of decision making, the quantum world makes room for a certain degree of uncertainty.
We hope that you learned something from this short video. And always remember that you're not irrational, you're just quantum probabilistic. Thank you.